So today's topic is stack. Again, it is one of the most important data structure. So compiler itself will use this stack at many instances. For example, if you know the recursive tree, how it works. So in the back end, the compiler will be doing the stack. So it will be calling a function, then again further function. It will be creating activation records here, like in form of stack. Then while coming out of the recursion, it will pop out all of these functions again and giving out the result. That is how it works. So let me show you how it works. It follows the last in first out LIFO. You have heard, right? LIFO technique. Last in first out. That means what? The person who enters last, he will come out first, right? For example, I need to insert 2. Okay, you insert that. After that, I need to insert 4. After that, I need to insert 6. So now 6 would be called as the topmost element. So it is at top of the stack. So when I say insert, it is actually called as push. So it is called pushing element. And the element which is at the top is called as the stack top. Element is a topmost element. After that, LIFO techniques means the person who entered last, right? That is 6 was the person who entered last. And if you pop the stack, then you will get 6 first. After that, you will get 4. So person who have entered the stack last, he will come out first. So that is about stack. You can imagine like there is a bucket here and there is a ball. It has a diameter equal to the diameter of this bucket. So you have pushed some of the balls, so you need to pop out each and every balls like this, right? So that is how stack will work. So let me show you to appreciate how this stack will be used under STL. See, this is a C program for creating a stack. So you don't need to. I'm just showing you how can I reduce this like nearly 30-40 lines of code into some 5 to 6 lines. So what I'm doing is I'm pushing the elements into stack. So this push function will be called and it will be keep on pushing the elements, and for pushing you need to write this much length of code, and I need to display the elements. So let me run this. So before that, this display will display all the elements in the stack. After that, I'm printing some lines here. After that, I need to pop and I need to give the element which I have popped, right? For that, I am running this function that is pop, which is this much big, and this is push. This is push actually. And this is a structure. So don't worry about this. After that, I am displaying again. So if I run, so this is how it looks like. So I have inserted 10, then 20, then 30. So while displaying, it will be printing from top, that is 30, 20, 10. Now I have popped. So which element will be popped? The element which is at the top, that is 30. So if I display, there is only 20 and 10, right? That is how stack will actually work. So let's remove this. Let's write our code, which we can complete this within 5 minutes, right? So include IOSTM stream, IOSTREAM stream. After that, I need a library called stack. CLUD include stack stack. After that, using namespace std, then int main. After that, inside that, how to create the stack. So stack stack, just like vector you have created, right? You can create any data type of any data type. So let me call it as yes. So yes dot push push 10, right? Push 10. Yes dot push, let's say 20. Then yes dot push 30. After that, I need to print out the elements, right? For that, I can simply I think print stack will work. let's say, I don't know, but this, so this will not work. So how to print it? Again, it is easy. There is again another, this is what about push, right? PUSH, push. So to pop, you will use pop, that's it. And there is top, it will give, so let me see out the topmost element. How to do that? S dot top, right? If I simply give S dot top, it will give me what? 30, because 30 is the topmost element, so I should get 30. So after that I'm going to use empty, right? Empty, this is for top. Next I have empty, so it will check whether the stack is empty or not. So let me see out S dot top, sorry, it's empty, empty, empty inline. So it will give me what? Empty function, right? It is a function, so it should give me 0 because it is not empty. If it was empty, it will be giving me 1. So now I should get 0. After that I am going to use size operator, so it is giving me 0. Now let me use size. So to check the size of the stack, I can use S dot size. So it will give me what? 2, because I have already popped 30, so it should give me 2. After that we are going to look at the empty is over, push is over, pop is over. So you can use front and back, so that I think that can be used in queue. This is about stack, pushing and popping out. So the size is giving what? It is giving us 33, right? Because I have not popped out. Sorry for this mistake. I have not popped out yet. So let me use pop, and here I can simply call pop. That's it. So after that, if I check the size, S dot size, so it should be what? 2. Should be 2 because I have popped out one of the element. That is 2. So top is over, push, pop, empty, size. So these are the only 5. I don't think there are many inbuilt functions for this stack. So this is enough for stack if you want to deal. As I said, push, there are only again 3 or 4 methods for stack, only that you are going to use actually to solve the problem. So this is about stack. So if you want to print stack, then what you can do is you can check whether if this is dot empty, right? If it is not empty, you can simply print is dot top, right? After that give some space if you want. After that you can simply pop one of the element, that is pop. So in this case I have only 10 and 20, so it will check whether this is empty or not. No, it is not empty, so it will print the topmost element, that is 20, right? So now the topmost element is 20 and it will pop one element, then again it will check whether it is empty or not. Then it is not empty, again top will be printed, that is 10, again pop will be executed, then the if statement will fail. Again I need to write while there, actually 20 while. So let me run this. So I should get 20 10. So I'm getting it. So this is about stack. In next video I'm covering the queue.